Hey, that's a good idea. Okay, so we are recording this now. Thank you. And it's May 1st, 1st of May. And we're just doing a compilation of some electronics and electricity and magnetism concepts from a couple chapters. So we're going to talk about charge primarily here. And it's just an imbalance of electrons to protons in an object. So if we look at all the atoms that make up an object, and we look at all of their nuclei, and we count protons, which we're not doing, they start off, if it's a neutral object, with the same number of protons and electrons, and that means there's no charge. There's no overall charge because the positives cancel out the negatives. This is pretty basic. You remember it from chemistry. If we are able to pull electrons away from an object, we end up giving the overall object a positive charge. If we add electrons to an object, we end up with a negative charge. Here's the thing. We can't make electrons. This is just like conservation of mass, conservation of energy. We trade them around, we shuffle them, we give and take, but the number of electrons present is fixed. And that's, you got complaints with that, go back to the Big Bang, go back to Planck time, take it up with, the universe. So we aren't making any electrons, we're just moving them around. You know this, and I talked with one group about this. Opposite charges attract while like charges repel. Same thing when you're making compounds in chemistry. Cations and anions form beautiful partnerships. Anions and anions, not so much. It's like putting the same poles of a magnet together. You're not going to get any attractive force. So the question is, can you charge a material? Well, we said if you can strip electrons or add electrons, yes. And there are differences based on the atomic structure in how materials accept the flow of charge. So you know this from chemistry. Conductors permit the free flow of electrons. So metals tend to be conductive. Insulators, the nonmetals and compounds made up largely of nonmetals, tend to be resistant to the flow of charge. They don't tend to allow electrons to flow onto them or off of them. You can charge either one of those materials, however, by contact to some degree. I mean, if you put a direct line of electricity onto even a fairly good insulator, you can build up charge. Not unreasonable. That's called conduction, and this is a word I do want you to be familiar with. Remember, that's a subtle clue. You should be able to describe to me what charging by conduction is. So when you charge something by conduction, you have a neutral object and you have a charged object. And when you put them in contact, electrons flow. So now they have the one that was originally charged is now neutral. The one that was originally neutral now has a charge. So the charge, let's think this through. I always have to think these things through. So here's object 1 with extra electrons. Oh, I know the difference. Okay. So here's object 1. No balance of electrons, and I'm going to make it very clear that object 2 is not grounded. So you remember what grounded is? It means that you're connected to the Earth. Extra electrons can flow into the Earth, or you can pull surplus electrons from the Earth, because the Earth acts as sort of an infinite reservoir. So if we take the charged object and we touch this, the extra electrons will flow onto here. So this new object is now going to have the same charge the original charged object did. Depending on how much charge and how long you leave them in contact, you may still have residual charge on the first object. That's charging by conduction. They're touching. And if you think back to heat transfer from physical science, do you remember conduction and convection? Do you remember physical science? Do you remember being freshmen? Do you remember yesterday? Just checking. Okay. Conduction means two things are in contact. So if you put a pan on a stove on a heating element, it is being heated by conduction because it is in contact. Charging by induction means the two objects are in contact. You did, well, first of all, let me ask, did you do some charging by conduction in the process of trying to figure this stuff out? Yes. You were desperately rubbing materials against one another, attempting to either add or subtract electrons. So whatever charging was done via conduction. You were stripping electrons. Okay. The other alternative is charging by induction, and this is the other word that I want to make sure you are familiar with. In induction charging, there's no contact between the objects. Well, remember we said in the last case that had to be unconnected to the ground? Because if it's connected to the ground, if it's grounded, these electrons are just going to flow into the earth. You know, the earth's a nice big fat reservoir. If that material is fairly conductive, it just loses the electrons. They travel through it, they don't stay there. Well, if we have two objects, one of which is charged, the other of which is not, and we take the charged object up against the uncharged object, we can get sort of a partial surface charge. I like to call it sort of like a weenie charge. It's not a real charge, but you know, it'll do for now. So the electrons just kind of line up. Okay, so here, let's do this again. We have a charged object, and we'll go ahead and reuse their thing. And increase the size on this. So if we hold that negative rod up close to this metal sphere, and it's right now it is not connected to Earth. We can imagine it's hanging or whatever. It's not grounded in any way. The first thing that'll happen is the presence of those electrons will push all the electrons in this other object to the other side. Because opposite charges attract and like charges repel. So here we haven't actually charged the second object. We've kind of given it like a partial surface charge. It's actually, we call it polarizing. We'll talk about that later. It's not charged yet. It's still got an equal number of protons and electrons overall in the whole entire object. But now, and this is the symbol in a circuit diagram for grounding. If we ground it, guess what happens to the electrons? They get the heck out of Dodge. These electrons will actually flow down into the earth. We haven't touched, you know, and then we can disconnect the ground. Let's see, how should I show that? We'll do this. So we can disconnect the ground, say that it's no longer grounded. And now what we have is an object that is charged and that actually has the opposite charge of the first object we were using. Does that make sense? Okay. Now, quick little three second, how would I make this a like fast trick you and get you to say things that you will then upon further reflection know are wrong? Because it's fun, that's why. Because I entertain myself with you guys. You're my unlimited source of free entertainment. Why do you think I went into teaching? Let's see. What if? Oh, I know. Okay, so I've got another object not grounded, rod with a positive charge. I hold it nearby, and sure enough, all the little positive and negative charges in the object line up. Not doing very well at drawing plus signs right now. So it's polarized, it's got a partial surface charge, it's got a weenie charge, it's not really charged. Now what if I ground it to Earth? So then these flow into the Earth, right? You people are better than I thought. Okay, why not? Why not the little pluses move? It's only the electrons that are able to move. We can't move protons. See, I thought for sure if you would go, yeah, that's how you negatively charge an object. Okay, I'm impressed, people. I'm impressed. Yeah, we can't move protons. So what happens in this case? Yeah, I mean, it continues to be polarized. It doesn't charge. So for today, does this shed any light on anything that you've done in the last 2 days? Not yet? Still muddy?
Yeah.
Okay, that's okay. But like I said, by Friday, you're going to have every single answer you need. So it's sometimes good to be a little confused and a little bit, frankly, pissed off, because it's a good mode for learning. So, all right, we're going to stop with induction, conduction. We'll pick up tomorrow. Happy travels.